I'm Paul Carroll. I'm a senior data scientist on the digital analytics and research team. It's formerly NHSX, so the digital transformation area of the NHS. It's now been brought into NHS England. Can I hand over to Mary, your introduction?
Hi, I'm Mary Amanuel. I work in economics and data science at the NHS, and I'm one of the co-founders of the NHS Python community.
I'm Ewan Wakeman, which you can probably recognise from that. I'm a data scientist with NHS England, but I've had to, by force, get involved in more of the engineering side of things over the time, and particularly sort of more of the ML ops end of the spectrum rather than the extract, transform, loady bit, which we kind of have relatively good coverage for. So that's why I'm here.
Hi everyone, I'm Faaiz. I work with Paul in the digital analytics and research team. I'm a digital data and technology graduate. I've been doing various bits of data science and analytics work. I'm working with Python for the past few months as well.
I will pick up from here. Right, so I just wanted to kick off by kind of giving a little bit of overarching context about the NHS, which hopefully will be familiar to a bunch of you, but I think like it's always worth kind of pointing this out to people when you start to present, which is like the NHS is not an organization. It is this like broad concept of a thing in which live like thousands and thousands of organizations that all kind of notionally work with each other, and then they like sometimes they do and sometimes they don't. And it is also ever changing. So like every time you get a new health secretary, they have a different idea about what the NHS should look like. We've had like 3 in the last year, so you can get a sense of like roughly how quickly it changes. And like when the dust settles, it's time for another restructure. So I think the challenge from an engineering point of view is like, how do you build in that kind of environment, in that kind of context? What do you do? And for us in NHSE, which is also formerly NHSD, X, I, HEE, and a bunch of other letters, is we think, well, we should try and present a little bit of the art of the possible. We should try and get people a little bit excited about this. We should try and get people to kind of understand what we could do if we all kind of worked to certain ways. And then kind of that is kind of the leadership. It's sort of a bit of kind of thought leadership and then showing the art of the possible to people. We also need to think about kind of low barriers to access. So like the different organizations all have differing levels of expertise in this stuff. And for a lot of them, it's pretty low down. Like they'll have cloud compute platforms and all the rest of it, but they don't necessarily have the teams to administer those, configure those, and run those in the way that you would kind of traditionally want from a kind of fully fledged solution. And so that is one of the reasons why we've kind of had a bit of a major focus on Python over the last while. It's kind of easy to pick up. It is ubiquitous. It is everywhere. It's built into every system. There are libraries, frameworks, code bases everywhere that you make use of this. And so it's quite an easy kind of low barrier entrance to get in. I should also point out, I put on this diagram again, patient, because I always have to come back to this. The reason we do all of this is because like people will live or die or have their quality of life as a result of it. So like trying to make this mess of things and cables work is actually ultimately the thing that like might mean that people live or die. So it's like, it's a bit mad to think about, but you know, that's kind of our context, I suppose. And that is, you know, the whole of the UK, we're in a slightly unique position there. So I won't dwell on this too long, and it's pretty text heavy, so sorry about that. But like essentially our challenges at the moment, tech stacks, we got loads of them. Everybody has their own one. They're all different. And there are like all sorts of different things deployed on all different ones. We're quite early in our sort of data science and data engineering journey, which means that like we're still at that sort of like quite immature end of the spectrum, typically speaking. People haven't really decided what their opinions are on how we should do this kind of stuff. They're more at the side of like, this is exciting. Maybe we should try and do some more stuff with like data science and these sorts of bits and pieces. There have been some early successes. So in particular, the COVID work that happened kind of really showed people that like there's some real possible like applications for some of this stuff at the moment, and they could really drive us forward. And also some of the work that kind of NHSX have done very early on in terms of proof of concept stuff has been really, really handy in kind of building that trust. We have a bit of a growing evidence base on how we should do these things. So like the fact that we've run some projects now means that we're actually able to kind of articulate a little bit more like how we think we should be doing this work. But there will always be kind of concerns around cost and security. We're a public body, so we always have to answer to these things. We always have to say like, how are we reducing cost and how are we making sure that we are being ultimately really, really secure with people's information. And there's paranoia around that as well as kind of a bit of a sense of they're important, and then like for kind of obvious reasons. So we believe really that kind of data engineering is going to be key to cracking this, like making sure that we have solutions that are like portable and like actually run on different architectures and a low barriers to access, and like think through some of those stages is going to be the thing that like helps us crack and kind of really bring the NHS forward. And I'll hand over to Mary to talk a bit more about NHS Python community's role within that.
Great, thank you, Ewan. So I just want to give a very brief overview of what the NHS Python community is, because that is basically the community that's sort of brought us here in a kind of weird way. So it's a community of about 700 people that champion open code and health in the NHS and wider healthcare sector. The audience is about 700 people, mixture of analysts, data scientists, clinicians, and healthcare professionals, people who are just generally interested in the power of like open source. And the real drive for the Python community actually came during COVID-19. So during COVID, there was a real insistence on analysts and data scientists to find novel ways of understanding COVID and to have very, very rapid analysis done very quickly with some sophisticated tools. The issue is there was no support network to help people understand Python and to help them understand how it's used specifically in the NHS. And so myself, my colleagues Alex, Craig, and Aruba thought we could help here. And I'm thinking about what Ewan's saying, and I think the NHS has a good understanding of what these core problems are, but I think there's a gap between knowing what the problem is and then finding the solution. And the question is, what do you do in the middle? You have a lot of analysts and data scientists who are trying to do excellent work, but where is their support? How do you motivate them to continue tackling these problems when there are these clear problems, and sometimes it feels like the system is against you? And that's where these kind of communities come in. We help people and we support people in that way. So there are a couple of reasons why we like Python. Ironically, I don't think Python's the best at everything. I'm not like a Python addict or obsessed with Python, but I think it does do a couple of things very well. And it's a good starter tool for a lot of our projects. So like reason number one, it is the most popular programming language in the world, according to Toby. It also integrates well with a lot of the annoyingly proprietary systems that we use. So we use a lot of PySpark and Apache Spark, which uses Python. And we found that it's generally a tool that can be applied in many, many use cases, whether you're trying to set up a medical device software, whether you're doing machine learning. So we think it's broadly applicable in that way. So I wanted to look at some of the challenges that Ewan was talking about and try to describe how the Python community tries to address them. So one of the issues that he highlighted here is, as you can see, there are thousands of mini organizations under a super organization. And something I found out whilst working at the Python community is that people don't really talk to each other. It's really strange. So people don't really know what, not even teams outside of their organizations are doing, but they don't even know what teams within their department are doing. And there is this sort of, not just secrecy, but this kind of isolationism when it comes to different project teams. And so one thing we want to do is improve technical collaboration between organizations, within teams, and within specialisms. And one of the ways we've done that is by obviously making a Slack that anyone can join. Across industry, across the NHS, across health. We have a board which has 10 people, including the head of scientific computing at Guy St. Thomas's. We've got clinicians, we've got data scientists from a mix of hierarchies, so ranks, and also from a mix of organizational structures, so from the local system and the national system. We also work closely with Analyst X, which is like other communities of practices that try to understand these problems in kind of different ways. And obviously we have all of these kind of project catch-ups, and Paul will go through geospatial very soon. The next challenge that we're trying to address is making coding accessible. So this is a twofold question. One is that it's actually very difficult to use Python in the NHS. And that sounds like a very weird sentence, but in an NHS laptop, the terminal is actually automatically deactivated. So when I say the system is very, very difficult to sort of motivate you to use Python, it is just fundamentally hard. And the issue is that every different organization has a different IT policy, and which means people have different rights to different kinds of technologies. So for example, this laptop that Paul has basically lets him access any apps, but my laptop and Ewan's laptop doesn't let us access many apps at all. And so there is this difference even between like software and what you can access. And the second part is we want to make sure that coding is an accessible thing. And this is more of a mindset issue, which is that most analysts in the NHS are just using Excel and SQL, but probably nothing more than that. And I ask people why, and there is a big intimidation factor. They think, well, I'm not a software engineer, I haven't done computer science, why should I learn any of this? And it's really saddening to see. So what we try to do is we try to actually create accessible resources for them so that they can learn regardless of where they come from. And I've just put in a bid for some money for some data science tutorials that was successful. So that will be coming very soon. The next part is this principle of being code first and open by default. So what we try to do is we try to build stuff transparently and in the open from the outset. So we try to publish code using like open source licenses. So it doesn't matter if you're hosting your code openly on GitHub, if it's not licensed correctly according to a government license or MIT license, no one else can use it. So we make sure to help people understand these licensing practices and to publish these things ourselves. You can see the projects that we have here, and we're going to present some of them as well. The next thing I want to say is there is something very powerful about doing these things yourself. So a lot of this is done in our free time. Like, we're not paid extra to do the Python community. It's on top of our like 40-hour work week. But by doing these projects, it allows you to have incredible amount of influence on the kind of standards and policies that are eventually made as a result of your projects. So we have contributed to open source policy, the Goldacre review, and competency frameworks of what a future NHS data scientist should be and what a future data engineer should be. And the last thing is we promote recognition. So I think it's very important to highlight and recognize people who have made contributions, whether they're big or small. And there are a number of ways to celebrate success. And we do a monthly show and tell to sort of showcase the kind of work we do. It's on YouTube, so you can watch everything. And we have had a conference, which is something I'll show you next. So I think conferences are one of the best ways to know two things: to understand the priorities in a sector and to understand what kind of work gets funded. So in November last year, we did our first ever Python community conference. About 300 people signed up, whether it was in person or online. And we had a lot of talks from industry, from the head of data science, to Sarah Culkin, to open source leads, to Google. So thank you very much, Danny, for presenting, to University of Bristol. So I would really encourage you to look at audience conference agendas to see what the priorities are and where we can find funding for these kinds of projects. And then I'll hand over to Paul.
Great, thank you, Mary. Hi, again, I'm Paul Carroll. I'm part of the digital analytics and research team, so formerly the analytics unit at NHSX. NHSX was like a digital transformation unit brought into NHS England. We're going through a merger still, where NHS Digital and NHS England will become one organisation by the end of this year. We're a multidisciplinary team of analysts. So data science is one aspect of what we do, economics and analytics is another, and we have developers and engineers. And I'll come back to that point a little bit later. What we're quite lucky we do, we get everything from ministerial requests down to, at the lowest level, I guess ICB or or trusts areas within the NHS. We don't really go any lower than that with the requests that come to us, mainly because they're medium to long-term projects. So our economists have worked on the NHS budget and continue to do that on an annual basis. We do works on the patient level information and costing system, the PLIX data. Analysts have worked on demand model simulator and analytics for consumer experience. My specialty is I do the forecasting for the NHS app, so it's not data science, but it's financial modelling, which is where I came from before the NHS. Data scientists have worked on workplace forecasting, synthetic data generation, GANs, geospatial, and we run a PhD internship scheme whereby we try and connect a lot of research to operations by involving and bridging the gap between academia and medical, the medical work domain. Developers and engineers. In NHSX, we had the first kind of platform, which was set up to build pipelines and process data. It may sound like we're quite a little bit behind the curve. That was only 2018. So we're bringing that into NHS England, but we've been able to productionize data and really put it into pipelines for use across the NHS. And it's only been something that started last year in NHS England. But that's, I guess, a good guide for where we are and what we're trying to move towards. But really, we work together to deliver asks from NHS trusts. And by each of these asks, what we mean is even if we solve the problem for one use case, it has to be open and adaptable to solve at least 3 different use cases that will inevitably come out of the woodwork at some point. So it needs to be packaged solutions that we can bring. You can't bring the data to the problem. It's the other way around, especially at trust level. It becomes very difficult to work with. Recent projects. So I've been working with ESNEF Trust, which is Essex and Suffolk Trust, on diabetes and inequalities. And that's a perfect example. We're trying to get patient pathways and examine pre-diabetes to post-diabetes, what's happened along the way. And you've got fractured information here. You don't have one source you can go to for primary, secondary care, A&E, diabetes centres. There's multiple touch points across this. So even trying to do that type of analysis is something that's a little bit difficult. But the repos we published on this, you may ask why we're publishing to GitHub. Well, everything we do is freedom of information request available anyway. So why not just have it out there in the open and have it accessible? We can learn from people who are better at doing this than we are. And it allows our work to be advertised around other trusts. So if we solve it for diabetes, maybe someone else can apply it for oncology or a different other condition. And a trust in Scotland can use the same work that we did specifically for ESNEF. Geospatial, thanks to Adam, Max and Nick. We've been working on this project from a pet project from last year, but again, this has got a plethora of use cases. I've published a few of the links here because there's a whole document on the use cases that we can take this work to, but I'll come to that a little bit later in the presentation as well. Synthetic data generation. This is a PhD project which we've parked for now, but we're trying to turn this into something that can be a research operation. So how can we generate synthetic data that's accurate on a distribution level, as well as something that's replicated medically and is usable by clinicians? MLOps, interoperability, feedback loops, all this type of engineering pipeline is what our developers and engineers do. Ewan's much better to speak about this than me, so I'm not going to talk about things I'm not as familiar with here. But I've just put a list of other projects we're currently working on, so hypergraphs and multimorbidities. A lot of the NHS works on looking at one condition or statistics on primary care, secondary care. What about the links between diabetes and hypertension, diabetes and cancer, other links? How can we view this for patient pathways, and when will we know that one condition will lead to another, and what can we do to intervene around that? So there's a couple other projects here. I said automating text descriptions. We will show you the GitHubs as best we can, but really, if you'd like to take a look, it's all out there, or the majority of our work is out there. There's no sensitive data in it. It's either anonymized or it'd be anonymized kind of group statistics, or it will be fake data, so generated data. Diabetes and inequalities. I'm going to gloss over this slide because I know where we are on time, but I'll go straight to the problems. We have data that's incomplete at patient level. We miss pathways. We miss gaps from primary care. GPs only put in a certain amount of what they think should be submitted, rather than following a generic kind of pattern of this is what we need to know. So we can't look at a whole patient pathway from 2004, say, to now to look at their pre-diabetes condition and what has happened since. This is my experience working with one of the trusts recently, and this really is the case. How do we deal with that? How do you interpret the information? How do you deal with incomplete mapping of something as basic as clinical code, so SNOMED to IC10? There's so many problems that have to be thought about how to solve this, and this isn't, when we look at these things as one trust, this is generic. Like, so we apply it to one trust and then map this across the NHS. We want to bring the solution to the data. 3 of the problems we've solved here, we've written as packages that can be installed on anyone's laptop across the NHS, providing they have access. And I think that's what's changing. We'll move to that area as well going forward. But it's needed for ESNEF, and ideally you want to build it into a pipeline where you can generate these statistics on a weekly, monthly, however you want to analyze them on that type of basis. Another project we're working on is multimorbidities. This was a PhD internship project where we just started mapping one type of condition to another, and saw where we could actually use hypergraphs to identify multiple conditions. We worked with the SAIL data bank on this. The real main problem we had with this was getting GPUs access to it, because you're looking at billions of rows of data for this type of thing. But what can we take this forward? And this is a project we parked and have the repo out there at the moment. We need to start really pushing this type of thing out towards other areas of the NHS and getting access to the data. There's other projects. I'm going to gloss over this slide. We were just using Python packages here because it's easy for us. It means we can either adapt it and change the code as we need to, but it also means any of the analysts within most of the trusts who do now have some kind of level of data literacy can use this very easily. And that by no means the standard across all the NHS. Some of the trusts only have one data scientist. They may have multiple analysts in somewhere like Imperial Health, but it could be one of the trusts, say in Lincolnshire, that doesn't have a very tech savvy or even have a server that they can run their data on. Large scale language models and incident data. This is another PhD project run by one of our students, Niall Taylor. This is an NLP project in pre-training approaches for language models, really to start look at how you would embed spaces and use performance really on sentence similarity. So could we look at documents and link them to other documents of the NHS and identify different areas of outcomes within patient level data? I'll move forward because I know we're a little bit short of time. Text Rareline was a project that we've worked on over the last 2 to 3 years, and this is one we want to take from research to ops. The idea of this was you take X-rays or any scans you can, and you use hundreds of thousands of reports that you get from radiographers or GPs, and the computer would predict, or at least write something similar that could be used to speed up what a radiographer could do within that space. I know it's not cutting edge because a lot of areas do this, but we're trying to do this within the NHS as well. So one area might be more familiar, especially for some of the guys in the room here. So Max and Nick, thank you for your help on this. There's a few areas of the NHS where we use geospatial packages already. Again, we can't bring the data to the software. There's Strategic Health Atlas and Planning Evaluation tool, very useful tool. It's effectively a whole load of data, but it's static and you can't bring patient level data into it. So if you want to cite, say, a new COVID unit that can go out and give booster jabs in February, you can't do this. You can't upload where your potential locations would be. The ask here for us is that we could give ICBs or trusts this tool, run it as a Python package. I think Faaiz is now working on the kind of max coverage location scoring issue. So how do you score a retail site, for example, like a McDonald's or an Aldi in a town? How do we do that for hospitals or GP practices? Or the other way around, what happens if the site drops out, gets overloaded, as we're seeing quite a lot with some of the areas of the NHS? Where do you divert those resources to? So this is something we're trying to build really with a lot of help from Max and Nick here, as well as 4 of us on this team working on this. Scoring locations is one area. The travelling salesman problem, something district nurses have to tackle every single day of the week. Patient lists for visits, environmental route planning. These are all the use cases I know the NHS is currently using, but people sit there and they do these things manually. So how can we just speed up what they do and get the low-hanging fruit out of the way and allow them to do something better? It can even go as far as things like scheduling of appointments. So, you know, are we scheduling them around bus timetables in somewhere that in rural that doesn't have a lot of public services for the elderly? And trend analysis, things like A&E services. So hopefully we'll have a tool soon where we can actually integrate a lot of these use cases and take it out there. So going back to, I guess, themes within these projects, a lot of what we try to do tackles one specific use case that came to us from an area of the NHS, but we try and adapt it. And over the course of the geospatial project, which was a 1-week project back in March last year, and it kind of came up again when we spoke to you guys at Google Health about how can you work with us. We identified a few more use cases with the use case document. But as you're running Python on a laptop, these things, some of running, you know, anything geospatial can take hours, especially on some of the laptops we work with. So Nick's been helping us with sharding, so geospatial sharding, where you can load areas of the UK a lot quicker. And Max has been working on tackling LSOA mapping. If you add those in together, those can become part of an equation for scoring a location for the NHS, which is what Faaiz and Mary both work on together. I'm working on multiple shortest route functionality. So a request from an ICS for where can they upload patient level postcode data and see where would be the optimal place for say a diabetes fan or a blood test fan to go out and be located within the trust. Obviously within that's highly sensitive data that can't leave that trust. So this is part of the reason why we have to build packages that tackle the lower end of what these aren't like a kind of wide holistic solutions. These are to tackle problems that they face daily, really. So the repo code can be cloned. It can also be spun up by technical users. And ideally, we could have a Streamlit app, which I showed the guys a little bit earlier, that can be run by non-technical users. So we've had a few user requests on this area, but by all means, we'd love to talk to you about it a little bit later as well. We're moving into an area in our team of research to ops. So how do we connect a lot of the repos and the projects I've just showed you and not leave them dormant? How do we bring these into operational use? So, you know, can we get to the bottom line? How many people are we helping here? Like, where is this going? Do we need funding to turn some of these into an alpha and then potentially beta further down the line? We do end the work with a release. Everything needs to be out there as far as we look. It all has to be open source. Providing it doesn't contain patient level sensitive data, it's fine. We work in a wider context. We try and define business value versus development time, but we're also managing expectations. So a software-like development cycle is something that's coming in. This probably shows where the NHS is versus maybe private sector, as well as other government organisations. I'm a civil servant with DHSC, but I was at the DWP, who've had a digitisation programme going since 2013. You can literally have speech to text from their phone calls of claimants making. The NHS isn't there yet, where you can actually analyse everything for one patient along patient pathway. There's technical transition plans in place. There's also working with potential stakeholders to identify both where we can widen the net for what we're trying to do and solve more problems with one kind of approach and time use. But ideally, we want a short feedback loop with all of these. So we need to have interaction. And that's where I think we're quite lucky. We talk to trusts on a daily basis. We talk to different levels of the NHS. We're trying to make sure we solve these. I think part of the users that Mary alluded to in PyCon, we have clinicians who code. I mean, God knows how they have time to do anything. But I mean, if you're doing that, then these are the kind of people we need to be talking to get feedback that what we're doing is going in the right direction. My brother-in-law is head of orthopedics at St Mary's, and just hearing problems they have on the ground is so valuable that it gives you direction for where your research and how to bring that into an operational use for what they need to do daily. Let me hand over to you. I think we're nearly there, aren't we, Ewan, for you? Yeah, sure. Sorry, it's my last slide, but I'll bring you over for this. So yes, the problem themes. There's no such thing as building a solution to a problem for the NHS. The NHS is a web. I can think of it as a fishing net over hundreds of organisations, GP practices up to ICBs, up to or trust within the ICBs, think ICBs, then think regions of England. IG restrictions are almost impossible. I think from my experience, we were working on a COVID database back in February last year, trying to do structural topic modelling to identify patterns within regions. We had to switch the analysis to a freely available database. We just couldn't get we couldn't get the IG agreement done in time for the research to take place. We need to produce reusable. We need to have packages that are reusable and are easily adaptable. And I think that covers 2 and 3. We're working on alphas for a lot of the use cases specified, so trying to bring some of these projects up to a level where they're not just a GitHub repo that can be cloned. Potentially, it could be something supported and hosted by us, and it can move into a full IT development cycle. Betas are for later development, but then we're still very early in our pipeline into production and pipeline integration with NHS data, and that's what UDAL, this central repository, will be, and that's where we're trying to move to with the NHS. Let me hand over successfully to Ewan. This is a sample slide of one thing we've done recently. This is last year's first kind of NHSX pipeline. I guess you might call it pipeline model for a product that took place, moving a forecasting tool into production, but it just shows where we are with these type of things. We have a platform, we have assumptions that are done by a variety of teams in Excel, and are moved into some kind of query database. We use GitHub as an output, but we don't use it mandatorily. It doesn't have to be used with everything, especially patient level data. We archive storage and we try and have a dev and production platform separately. But this is just a very generic sample of how we work in different areas. Oh, it's you. Sorry, I got it wrong.
So one of my jobs in the NHS is to actually brief the national COVID response teams about when we expect the next COVID wave to come. And it's quite a big responsibility, I would say. And due to that responsibility, we have created a tool, machine learning tool that gives basically probabilistic estimates about when we will expect COVID to come, about 3 weeks in advance. And there are a couple of necessary things, obviously. So the data has to be timely, it has to come every day. The actual predictions have to be as accurate as possible. And if they're not accurate, we need to be able to explain what kind of uncertainty we would expect. So these forecasts show daily admissions for COVID, the amount of people that need to use mechanical ventilation beds, so oxygen beds, related to COVID, and how many people are kind of using COVID beds. And the benefit to this model, and this is actually a very award-winning model, won lots of awards and was very, very pivotal to the COVID response, is that it uses Bayesian hierarchical forecasting, which basically, in a simple terms, helps the NHS not just understand what's going on at a national level, makes predictions at a national level, but also at a regional level and also at a trust level. So we have predictions for every single trust about when they would expect to have COVID. So it's not just helping the national level, it's helping individual hospitals manage their capacity in the long term. We use data from 111. 111 calls, these are called leading indicators that have a sort of correlation to our core metrics, and we use time series data from trusts that they submit into our sort of database that we sort of use data from. And yeah, basically it helps us manage capacity and crisis management, and it was very, very crucial to the COVID response. I recently got feedback from National Clinical Director that this is the best forecasting model for COVID around. And yeah, I just want to show you that the impact is very wide. It's used across basically the whole of England, and it was very, very critical to response. And the reason why we wanted to show this project is for a couple of reasons, and Ewan's going to cover most of them. But I just wanted to show you the front end. So it's quite a simple front end. This is a tool where you can basically see the black dots are actual COVID admissions into hospital, and essentially the pink is where we predict COVID, the admissions to fall, with the middle being like the central forecast, and the pinks on either side being sort of the uncertainty or confidence intervals. And even though this looks relatively simple, this was an extremely, extremely impactful piece of work. And I think what this simplicity hides is actually how complicated the underlying architecture is, and Ewan's going to go through this. And even though the architecture that we have is not perfect, doesn't mean we can't have incredible scalable impact with our imperfect architecture. So Ewan, do you want to come and we can talk more about engineering problems? Thank you.
So I'll try and tie it up with a bit of a neat bow. So to give you a bit of an idea of what's going on in the back end, and then sort of try and bring it together as to like why I think this is important and where it probably makes sense for some of you guys. So like at the moment this is a very, very simple diagram of kind of roughly what happens. And I just want to point out essentially that we've got one version control platform, which is separate from the 3 different cloud platforms that we use at some part of this pipeline. So I think it's fair to say that we've not really settled on what our given solution is as an organization yet. We've tried out various different things, and because of historically where data has lived and what tools we've had available to us and configured to actually be able to run the stuff we want to run, different parts of our pipeline have lived in different places. So we have source code coming through in one place and generating kind of pre-configured Spark environments where we've got source data coming from a slightly different platform. Then we do some data pre-processing, some model training, and then we have a separate platform for doing some model runs for QA and improvement and for doing some model development. And then there's some post-processing, which also lives in some Git-enabled but private repositories that live within a certain system. And then we get some storage and some visualization. So that's like our sort of simplified version. This is a slightly more detailed version of the architecture. And I think really what I want to point out from here is like the blue box and the red box, which is just this idea that like actually to get this thing running, we're calling some data in from APIs into memory from one thing. We're pushing things back on schedules. We've got like various PySpark repositories dumped around in different places doing elements of pre-processing and elements of post-processing. We've got kind of some Stan code kind of actually dealing with the bulk of the forecast, but we also need to replicate that Stan code in a different cloud environment because we can't get our production environment to quite do what we want it to do in terms of metrics and kind of actually like the development process. And as Mary and Paul have already mentioned, the NHS has differing approaches on how it wants to give you access to stuff. So all of our development work is cloud, has to be cloud, because we can't really get anybody access on their machines to be able to do any of the basic like coding and things. So, you know, if we want a VS Code instance, it's in a browser. If we want something else, and we have to pick up a system that uses those sorts of things. So like, why is this relevant, I guess, is like, I think it's important to understand like the NHS really hasn't decided on what its pattern is yet. And the thing that what's going to help us win out is going to actually be, can we present to people tools and like a sense of the art of the possible? And can we, in doing that, do it in such a way that kind of actually showcases like the best ways of doing this? We're going to have to be extremely modular. We're going to have to think about things like being able to pick up things and take things to data. We're going to have to think about like making sure that things run on different architectures. We're going to have to think about how we're meeting people at different levels of that journey and kind of with different levels of experience and skill. But actually, as kind of this has shown, we've got a pretty messy and organically growing back end that we're now trying to migrate into something more sensible. And we've been managing to keep the front end going for like 2.5, 3 years now, by hook or by crook. And the fact that we've managed to keep it going is what's won people over to the idea that like, hey, maybe we should do something with this back end because this looks a little bit messy now. If we hadn't have done the first bit, we'd have never got the license to do the stuff that we really want to do, which is like can we actually make this useful and usable and push it in the back end? So I won't kind of spend too long on this because I want to make sure that we've got plenty of time for questions. But essentially, like it's this, we have a real kind of lack of a clear development environment, which is like a real challenge for us internally. So like anything we can do to get open source solutions developed means that we can spend less time away from the types of platforms that we might be using for production that aren't particularly good development environments, and we can actually build things in the open where we have access to all the tools that we want and then bring those solutions to the data, and we don't have to worry about that security point so much. We've got a bit of a reliance on proprietary software and systems at the moment, which we don't like because, I mean, it means that we can't port them to the people who really need them most. We can't port them to trusts or to GPs and other things. But also, you know, we want to be flexible. We want to take advantage of like the best cost for money and like, you know, sorry, the best value for money, not cost for money. And we want to do all of that sort of stuff. So like we need to build things in this way so that we can test out what is best for our use cases. We've got a mess of kind of APIs and tokens and syncs kind of going on left, right, and center. We want to consolidate that so we've got a manageable pipeline, which we can all focus on our skill sets. And we're probably using quite a lot more compute and storage and these sorts of things. And every penny we save is something that can go somewhere else in the health system, is something that we can use for actually genuinely benefiting people. So like there's a real challenge, but I think we've started to win the battle on this can be genuinely useful. And anything more we can do, particularly in the open source space, to like nail home, you know what, like this kind of stuff can be really, really handy, really, really useful for people, and it can genuinely save lives if we do these things properly, and we can get the system running in the way that we want it to. The more that we can do that, and the more that we can showcase by doing that the ways of working, give a bit of an opinionated software sort of design approach to like how we do things as the NHS. The more we get that kind of nailed home, the more we'll kind of lead the sector of organizations and mess all around us to kind of start working to the same patterns, to start designing things in the same way, and the easier we make our job. And that's, I think, basically how we're needing to make progress. Sorry, not process. We've got a longer list here of various engineering-based issues, which I'll leave up just in case they're of interest to anyone. But I think kind of like mainly all we want to really talk to you now about is like take some questions, have a chance to grill us, because there's honestly so much going on in this space that like we want to hear from you as to what you're interested in and how we can like help with that.
Is that the deck done? Yeah, I'll switch to cameras. Okay.
Cool. Any questions?
Thank you.
Thanks.
Paul may know a little bit more, so I'm not like too experienced with like the use of fire, but I do like kind of recognize that there is like we need standards. Like we absolutely need like standards in terms of like how we work with things, and like they are one of the key ways in which we can like actually start to bring stuff together and make sense of what we're doing. So wherever we've got those sorts of things to kind of help us out and give a bit of structure to some of the work that we're doing, that's really, really helpful. I'm sorry, like to double check, by fire, you're talking about the FHIR fire, right? As in
yes,
like the
yes.
data standard. That's correct. I just wanted to check because like you never know. Like sometimes there might be another fire. I mean, lots of things are on fire if that helps. But
Oh yeah,
yeah. So like, I mean, like anything that we can do to like have standards or like showcase standard ways of working. Like we need to kind of generate opinions on how we do things, and where there's already a solution that has an opinion, like absolutely, like let's stick to it and let's use it. And as we kind of previously mentioned, we are bringing solutions to data normally. So like knowing that data is stored in a specific format means that we can develop solutions in the center, because I have no chance of getting hold of any data stored in fire format ever, but I can look at the stuff, fire format documentation. I can say, okay, well, I know at least what's in there. So I might be able to build a solution that kind of like uses that standard. That makes sense.
Yeah, and just to allude, there's a couple of examples that are out there already of things like Open Safely, which was run with NHSX and Oxford University. Was set up is basically an SDE, a TRE. So we're alluding to a lot of the terms secure data environment, trusted research environments that were set up for different users within DHSC and the NHS to be able to access data, and you can access it through a variety of levels, right? And these guidelines and fire guidelines are built into those type of templates. That's where the NHS will be moving to. We're already kind of trying to move away from, let's get the data and make it so secure that no one can use it. It's in a black box buried under, buried in the ground somewhere, and moving towards where people can actually access and try and do their job daily. We're not there yet, but I think there will be a model I don't think any of the models we're using are something that's new, that's going to be generated. We're just taking examples from private sector, from other areas of industry, and applying those to where they need to be used best. I think the Goldacre review that's come out, which is fundamental to what you're talking about, that's an area of practice that's being incorporated, but they only came out last year with 190 recommendations. So it's a long way for getting them all put into. But hopefully, the way we see things is moving to more of a model that we see elsewhere in government, where in 5 years' time, it might look a little bit like the DWP and the digitalisation platform that they have. I hope that answers the question a bit more. I've only really seen that in example. I've only really seen that really work twice so far, whereby we packaged it and used it across. And we don't have access when you're doing that and you're giving the package to someone else to use. We can't see if it's running well or not. We're not allowed to look at the data. So I've got 4 of these laptops at home, one for each trust I work with, and the main one for NHS, because that's where they are. They're not like when I was in the private sector where you'd have a portal and you could log in securely. But we will be moving that way, I hope. We just get feedback, and that's the main thing that really allows us to take this package forward. So the whole geospatial thing came up from 2 requests. I think that came out from policy, digital policy unit. And we built those in, and then it went to sleep for a bit. Then another request came down the chain from my boss to me, and Google guys got to get involved. And from the back of the PyCon conference, we've had another load of use cases that come up. So I think it's more of a kind of way of thinking that you have to assume there's going to be a multitude of use cases for these things, and make sure that it's open enough that it can be adapted. It can be as simple as just having a data uploader that allows an analyst in SNF to upload their data into a format, or it can be making sure that the data analyst there understands a bit of code and you can guide them through it. But you only know the results and how it's being used once they tell you it's rubbish, it doesn't do this, can you change it? And that's a feedback loop that we will. It's what supports the software at the end of the day. So we don't learn anything unless it's working well.
There is the essence of a strategy. There are some ideas that are floating around in the ether. I think like that's probably a little bit unfair, but I think where we're coming from is we're coming from an organisation which for many, many years has done like performance monitoring and analysing. NHS England was set up to like deal with like how do you distribute the massive, massive, massive chunk of government money amongst the thousands and thousands of bodies who need it, and how do you make sure that you encourage the bits that like are doing a good job to do better jobs, and like stop people doing the things that they shouldn't be doing, whilst making sure that you have enough money to care for people. And so there was this huge kind of performance monitoring thing, and over a number of years, kind of when I joined the NHS, which was back in 2018, so not that long ago at all, there was a real focus on like business intelligence, right? Dashboards, dashboards, dashboards. The more KPIs we can put on the dashboard, the better the dashboard will be. And then everyone went, this is nonsense, we can't understand what this is. And so there was a bit of a flip then to be like, well, can we build models, and can we do data science and those sorts of things? Because that might be more interpretable, and we can give people information about where things are going to go, or like we can help them to like design stuff that's more useful, and we should focus on that kind of stuff more. So what we now have is this like situation where people are like, right, we've kind of understood there needs to be some stuff about like kind of getting data together and cleaning data up and kind of creating some kind of business objects type logic, which like we can give things to analysts, not from like 18 different data sets that all notionally talk about the same thing, but rather like, here's a patient object, and here is a operations object, and here's a medicines object, and here's a like A&E attendance object, and therefore like they can build tools using those sorts of things in a more straightforward way. And then we've got kind of there's a sector more widely looking at things like fire and various different ways of like coding and standardizing their data, and so we've got all of that going on. I think what we're trying to push on is like there's a whole separate like world of engineering challenges for like getting data science working. Like it's all well and good to like build a model that you've like thought about, but like we don't really have any data in the center, and everybody has their own bit of data, but that might look slightly different. So like there's this thing of like, how do we actually like wrap up the IP, wrap up the thought process, wrap up the model, and actually like get it to the data and get it to the people who can use it. And that is a bit black boxy at the moment, but it means that like there's this bit in our strategy which I think it's a gap in kind of, we haven't traditionally done this stuff, so there's a bit of a gap in our knowledge base in terms of how do you actually deploy models? I'm not talking about how do we transform data, how do you deploy models in different contexts? And I think there's there's an ambition from our leadership that they want to do that kind of work, but there's not necessarily, they don't really have opinions on how it should be done, and there's not necessarily much of a sense of direction. So what we're trying to do is be like, well, if we kind of start showing you some ways that you could do this, and if we start having some opinions ourselves and we start kind of putting these things forward and we say, well, actually, you know, we're going to build things in the open because then everybody can pick them up and use them. And it also provides this like nice, transparent front to what we're doing within the NHS. So people don't think we're doing nefarious things with their health data, which is another problem that we always have. Then we kind of think a little bit like fanatically about like, how do we make this as simple as possible and nicely wrapped up as possible to give to people to kind of do the thing. Then we can turn around and say to the leaders, this works and this should be your strategy and this should be the way that you're doing things. But I think it's always going to be a little bit bottom up. It's never really going to be top down because we just don't have the experience and expertise within the organization to say, you know what, like this is our focus for how we do data engineering and data science. We will have to role model it for them and then kind of say, and these are the benefits and this is how we deal with those security challenges and all the rest of it. So that's kind of where we're at and what we're trying to do at the moment.
NHS Digital is the area of the NHS that really deals with NHS data, you know, collection, distribution, NHS websites. They have a synthetic data tool that is locked down for only NHS Digital users at the moment. They're going to be integrated into NHS England at some point later this year, but that does mean that if any of us here send a request for a data set to be you know, manipulated or created on the back of real data for these variables, it invariably doesn't get responded to. So we've taken it upon ourselves to just create styles of synthetic data creation based upon fundamental real data sets that we have that replicate distribution that are useful within clinicians' area. But we're only at the stage of designing these type of models at the moment. There's been a couple of PhD projects within the NHSX repo that are published on this, and SynthVAE is one of the tools that my boss at Carroll making, I think it was sometime last year with a couple of PhD students. But that's a fundamental problem we're trying to solve for research purposes. So what can we get that really replicates the underlying data? What can we use within conditions? You know, can you specify a cohort with this age, with these conditions, and can we do research on it? We're waiting to see what will happen when NHS Digital moves into NHS England. Do we suddenly get access to these tools that they've fully got instead of us having to run these ourselves? So it's not something I can give you any more of a direct answer, I'm afraid, than what I've just said on that, unfortunately.
So I can answer the latter part, which is, so I think so we work in the CDAO, which is the Chief Data Analytics Office, and I think there's 600 analysts just in our department. And there is Analyst X, which is a community of 16,000 analysts. So that's probably the scale of analytical workforce. Like I said in the talk, the actual problem is not necessarily, well, we need more analysts and mostly more data engineers in particular and data scientists. But the analysts that we do have are using SQL and Excel and usually nothing more, or maybe like Tableau. So there is a sort of a skills gap between what we need to be able to tackle these problems and what the average analysts have. And this is why we're kind of talking about these issues. This is why we are trying to broaden our net about who actually has these tools. So I think there is always a demand for analysts, and actually that demand is growing, and we don't actually have enough, but the skills that they have are not sufficient to deal with these sort of engineering challenges. And Paul, do you want to talk about the packages?
Yeah, recently a good example has been the ESNEF Trust. So we've produced packages for their diabetes analysis on 3 different areas. One of like a do not attend risk predictor tool for some of the patients. Another one about the whole diabetes inequality spectrum that we can't share on GitHub because it uses proprietary data of the underlying patients. But we took the analysts through how to run the package, how to use the software, and record, put everything out, instructions for GitHub repo with readmes, private ones in this case. That's our education level of taking it to them and then leaving it with them to, you know, try and let them get off the ground with it. But the other option is something we're doing right for geospatial. So you have 2 solutions. One is to produce code that a technical savvy user can run via terminal or run via iTerm, or you have it as a link into a Streamlit app or something that can be taken to the data again. So there's options. Those are just a few of the areas that we covered with this. We're really not there is a huge data literacy gap, not just in our stakeholders and educating them about the data that we have and saying this is what your model will tell you, and you really need to trust what's underlying it, but also the skills gap. In some of the trusts like Imperial College, you can imagine the data science area of that trust is huge. Whereas you look at places like Lincolnshire, maybe it's less so. They only have 1 or 2 data users and really not any servers paid for by the trust either. So we're trying to bridge that gap.
You want to tear your hair out, right? I think we have to go about it the other way because there's no other option, right? Like, we could pretend that we live in a world where like we know what the data looks like, and we understand it, and we could like build things and give them to people, and they go, "Oh, this is brilliant, it works." But in reality, we know if we do that, the first thing they're going to come back is say, "This doesn't run on our data. This doesn't work. It's not. This isn't what it looks like." But at least then we have the conversation about, well, what does it look like? And I think this is ultimately where we're at in our kind of position at the moment. It's like field of dreams stuff. We have to build it in the hope that then they'll turn up and tell us it's all wrong, and then we can correct it and give it back to them. And like it's about starting that conversation by like presenting the art of the possible. I think one of the interesting things about synthetic data creation is like a lot of the focus on synthetic data creation is to give ourselves a data set so that we can build something to then go out to people and say, like, we think your data looks a little bit like this. We've built some stuff for it, but if it doesn't look like this, then we might have to change that. But can you tell us what it looks like, so then we can change our synthetic data sets and also change our products so that they work for you? And the other end of this is like, we also don't know what their systems are. We don't know what cloud platforms they're using. We don't know what tools they have access to. We don't know a whole bunch of stuff. So what we do is we kind of, well, Python's pretty common. Let's build some stuff in Python. It's quite low barriers to access. Lots of people write it. If you've got data scientists and data engineers in your team, there's a chance you've got some Python users. Let's build some stuff. Let's show it to them, and then let's start that conversation. Because otherwise, we were kind of destined to stay in these silos where we go, well, we can't build anything because we don't know what your data looks like, and we don't know what your cloud platform looks like, and we don't know what your architecture looks like, and all the rest of it, and it doesn't work. So what we have to do is we have to kind of start that conversation and say, you know what, like, we think this is a good way of working. So we'll give you some stuff for free. You can tell us where it doesn't work, and then we'll adapt it, and we'll start our working relationship that way. And hopefully that's the way that we start to pull everybody into the same sort of direction and ways of working. But it's kind of, yeah, it's a challenge, but like it's an interesting one, I think.
Can I add quickly? One thing we do is we go to the trusts. If we need to, then we'll go and help them set it up and get it to run as well. And a bigger issue with that is not just adapting it to what they need is, but dealing with incompleteness or missingness within that data. Like, how do you interpret? You have to have real thought around each use case with them about their data. We're going to be doing that with EMAS, East Midlands Ambulance Service, soon. And we've been doing that with ESNEFT as well. So it's either you get a portal that you can log into or use their laptop, or we go directly to them and help them adapt it to their use case.